Greetings and welcome to Cota Access. My name is Joe Blair, and I venture here at Cota, investing in early stage venture investments. I'm getting a little bit of feedback, but let's just check that. And I'm the moderator today for Cota Access. So Cota is a multi-stage investment firm focused on public and private modern enterprise technology companies. The company focuses its investments on modern infrastructure, workflow automation, fintech, and health tech. Cota is SEC registered and based in San Francisco. Cota Access brings together founders, thought leaders, and leading executives to explore a variety of business and technology trends and topics that fundamentally impact our society. Today, I'll be discussing with the panelists you see before you, the adoption of edge computing. So I'm going to start by just briefly defining and introducing what edge computing means to Cota, as this term has been thrown around for a few years, and even experts in the field are constantly confused or differ on what edge computing really means. I'll then give our panelists a chance to introduce themselves, tell us more about their companies and some of the exciting products they're working on. Then we'll launch into a discussion about the latest trends in the space. And for our viewers, please don't be shy about submitting questions, as we'd love to get input from you all and answer your questions. So first off, what is edge computing? So Gartner defines edge as the physical location where things and people connect with the networked digital world. They define edge computing as part of the distributed topology where information processing is located closer to the edge. So for context, let's remember that the number of Internet of Things, IoT devices worldwide is forecast to almost triple from 8.7 billion in 2020 to more than 25.4 billion IoT devices in 2030, according to a 2021 report from Statista. And each of these devices is generating a large volume of data, all of which requires processing. Now, traditionally, the majority of IoT devices would send their data back to the cloud for analysis. However, if trillions of gigabytes of data are sent to the cloud all at once, the data pipelines get clogged and the round trip takes too long to be useful. Edge computing brings together the power of computing closer to the data, the applications, and the users. So whether a camera with AI-enabled computer vision or an autonomous vehicle, edge devices can process some or most of the data locally and just send the rest to the cloud. So simply put, the world will no longer come to your IT. Your IT will need to go out to the world. So now I'd like to introduce our panelists. So here we are. Our panelists will help us take a closer look at the edge, what it is, how it's changing, and where the business opportunities are resulting from this shift. We are extremely fortunate to have such exceptional panelists joining us today. So Andreas, let's start with you. Feel free to introduce yourself.
Thank you for having me today, Joe. Maybe a few words about us. Our group is one of the fastest growing consumer IoT SaaS category leaders. And our mission is to make life for consumers more efficient, comfortable, and secure. Now, how are we doing this? By making modern technologies user-friendly and affordable for mass markets. So in other words, we are bringing IoT to everyone. We have a consumer-centric approach, and our value proposition is driven by our services. So our full-stack platform, which we control end-to-end, enables us to offer IoT as a SaaS solution and to run a real data-driven business across different product verticals. We launched our services in 2015 as the first and only company to pioneer a 100% cloud-based IoT SaaS offering. Today, we have users in over 180 countries, offices and teams in the US, Europe, and Asia. And we started with smart home security, and the group is now scaling gradually into other verticals such as smart door locks, healthcare, pet care, baby and child care, wearables, and many others. And the edge computing actually plays an important role for us, given we have a lot of devices in our customers' homes. So very excited to be here with you guys today, and thank you very much.
Thank you, Andreas. Now, Garrett, please take it away.
Hey everyone, excited to be here. My name is Garrett Larson, co-founder and CEO of Rhombus Systems. In a nutshell, Rhombus Systems provides cloud-managed security cameras and IoT sensors, specifically geared towards enterprises and large organizations, say like commercial real estate organizations, education or schools, anything like that. We've been around for a little over 5 years. We primarily deliver all of our devices are delivered at the edge, so it gets rid of all the complicated hardware that was usually necessary in our industry, such as servers, NVRs, DVRs, and so we really leverage our edge devices and then stitch it all together in the cloud. We're primarily based in the US, but we have deployments around the world, and looking forward to talking about how edge devices are kind of disrupting and pioneering kind of a new paradigm.
Thank you, Garrett. Nigel?
Well, good morning. Good morning, everyone, and really excited as well to be here. Thank you to Cota for putting this together. So what we at Quadric do is we're building a new processing architecture that's enabling all of these applications that we're going to be talking about, the ones that Andreas and Garrett are building, by essentially providing compute, high performance compute at low power ranges, so that it's capable of being, all these algorithms and things that we need to run at the edge or that we desire to run at the edge can actually run at the edge and don't have to suffer the round trip latencies that Joe was alluding to earlier. So really excited to be part of this and to kind of give a different angle based on as we see ourselves building the enabling platform for many of these applications.
Excellent. Well, thank you all for being here. We appreciate it. So Andreas, let's start with you in terms of getting into our questions. So first off, what has changed or is changing to either promote or hinder the adoption of the edge?
Yeah, that's a good question, Joe. As you were saying in your intro, there will be a huge uptick in devices out there. And many of these devices will generate huge amounts of data. For example, in the booming autonomous car industry, where activities like vehicle operation and in-vehicle content are essential to deliver value to users, it's expected that cars will generate 1 terabyte of data per day per car, which will in many cases require real-time processing and immediate feedback to the user. And the same trend can be seen in the smart home security industry, where the latest devices are already adopting very high resolution 4K image sensors and to deliver better image quality to users and to enable software to perform advanced computer vision tasks with greater accuracy. And so one of the biggest challenges for the IoT industry is that the evolution of sensor technology and hardware does not match up with the speed of improvements in the widely available data transportation technology. So in fact, as you can see in many research, it has seen that over the last 20 years, processor power has increased by a factor of 1015x, but data bandwidth capacity has only increased by a factor of 104. So this limitation for newer and better ideas on reducing the distance between the source of data and the place where it is processed, this is where the concept of edge computing becomes extremely relevant. So based on what we see, the key dimensions which drive the discussion around edge are driven by latency, bandwidth, and cost. And therefore, competing solutions for this are, one solution is to bring low latency fiber into customers' homes. And we are seeing in countries like Lithuania, Sweden, and Norway that over 90% of homes are connected via fiber. However, for most households, this type of low latency internet connection is not yet available. Hence, having smaller data centers closer to the location where the data is actually being generated will be very helpful. And regarding bandwidth in an IoT context, there are a few applications which require large bandwidth, in particular home surveillance, which is the business Canary is in. So here we have an adoption of edge computing in devices in a it's a very relevant factor for us. So, and then last but not least, you have cost as a key factor, especially when being a B2C business in a mass market. So we need to balance the ability to process on the edge versus the cost for the processors used in the device. So IoT applications that explicitly require low latency, like smart home security, are already implementing this approach. They are offloading heavy processing tasks like object or face detection directly to the edge, and consequently reduce the time needed to notify users when something relevant is happening. So in a nutshell, what we strive to do is to have raw calculations on the device, and then followed by pushing the initial results to the cloud for further analysis and processing.
I guess I might add to that and just echo what Andreas was saying. We see a lot of the same trends. The statistics on processing power versus bandwidth are something I wanted to highlight as well, and add to it. Software developers aren't satisfied with no matter how much processing power you give them, right? And so what you see is, despite the processing power going up, the nature of algorithms is getting more complex as well. We see this in neural networks with just the raw amount of compute that's required, computer vision tasks, and the more complex computer vision tasks requiring more processing power as well. So despite the fact that we're increasing processing power, it's still, perhaps a game of processing power versus the algorithmic complexity. And as a result of that, there are still applications that are being processed in the cloud because you do have more processing power there. But as we and other companies build some of this enabling technology where you get different compute architectures to be able to provide the performance required for some of these newer algorithms, we're going to see that edge deployment increase yet further. And so I think that is one part of it. And the other, I think, is we're seeing in some of our customers, but not all, the privacy issues that will start to come up. I think those are in kind of their infancy at this point, I would say. But I think consumers and certainly governments are paying more close attention to that, and we will see that as a growing concern going forward.
Yeah, and just kind of round it out, I'd echo everything that Nigel and Andreas were saying. I think Rhombus being around for just about 5 years, it's amazing to see how far the edge has come just in those 5 years. When we first started, what we could do on a camera was very limited. Usually it was just recording footage. And even at that time, it was just the idea of recording a lot of footage to the camera was somewhat new, just with the amount of SD card storage you got. And just in this 5 years, we've gone from a single core processor to 4 core CPUs that can now do facial recognition, that can now do license plate recognition. So I think, as they're both saying, just getting that compute power and getting it to the edge has really advanced a lot in the last few years at a reasonable cost too. It's got to be at a cost that an end consumer and end business will buy. And I think as we get more of that compute to the edge, it's really beneficial to the consumer because, as Andreas was saying, the turnaround time is really quick on things like if you want to do like real-time facial recognition, you can do that. But there's always still the cloud there that can help augment, which I think all of us still rely on that too. So. But it's been fascinating just to see how quickly it's been going in the last few years.
Yeah, just wanted to follow up. I mean, Nigel mentioned privacy. Garrett, you mentioned facial recognition. So Garrett, can you comment on which regulatory business developments are helping or hindering progress at the edge? So, for example, GDPR, other privacy regulations, innovation initiatives from different countries, high-speed internet access, 5G, fiber.
Yeah, so I don't know if I would go so far as to say anything's helping or hindering. I would say it's all getting defined right now, and it's really interesting to see how the landscape is quickly changing and getting defined. You mentioned GDPR, which for those of you that don't know at a very high level, and I'm no expert in this by far, but it's just a set of consumer privacy regulations that the EU adopted. There's an equivalent that recently California has been spearheading called CCPA, and I think it's going to go to the next phase is like CPRA. And all of these are meant to help with overall privacy. I think where it affects folks like Andreas and myself is in privacy areas like facial recognition, license plate recognition. These are obviously very sensitive subjects. And this is something that will just have to be defined as we go along, both by politicians and regulators, and with the help of tech companies as well, as we're trying to push the envelope and also trying to make sure that we respect the privacy of the people this affects. So it's still a moving target, and I think there's still a lot to be defined there, but it'll be interesting how it all shakes out. And I'm sort of curious to hear other people's opinions here, like Nigel and Andreas.
Yeah, I just to follow on, I wouldn't say that we're directly affected by any privacy regulations firsthand. Some of our customers are, and certainly in the spaces that you guys are talking about, facial authentication or recognition being one of them. There are some countries and companies that are definitely more privacy centric than others, as we all know. But I think that's really pushing for a lot of this to be done at the edge so that you circumvent or you negate those issues, right? Those privacy issues. If you're able to say, I can do all of my facial authentication tasks on the device, just like we have Face ID on an iPhone, I think you really negate a lot of those concerns. So I think that we are starting to see in some of our customers. However, I would say for us as a company, really the technology and the requirements around a lot of what Andreas was saying earlier in terms of bandwidth and the round trip latency are really what's driving the move to the edge. Just for us, autonomous driving and self-driving or a lot of the ADAS features that we're going to see coming out in cars in the next decade are dependent on really, really high bandwidth sensor streams. And it's not just image, it's LiDAR, it's radar, et cetera. And we just don't have the connectivity. We don't have the bandwidth, even within the car, to be able to do processing, even in a centralized place in a car. And so what we're starting to see is this push to, what I would call the edge of the edge, where compute is being done on the bumper, for example, right? Rather than trying to transmit that really high bandwidth data to a centralized location in the car. So I think a lot of these things are being driven by pure technological problems. And as we've seen as a society, governments and consumers are kind of catching up with some of the implications of that.
Nigel just coined a new term we all need to propagate: edge of the edge. You heard it here first. Andreas, could you give us the consumer perspective on this?
Yeah, sure. So I agree with Garrett and Nigel that privacy regulation is currently one of the big drivers behind the adoption of edge computing. And as we're looking at these topics from a B2C business point of view with customers in many different countries and jurisdictions, we have to manage our approach to data to be in compliance with local laws and regulations. And we think that what we see these days in terms of new data protection regulations and strict enforcement of data privacy, it is not in the interest of IoT product manufacturers to continue sending higher volumes of data directly to the cloud. So for example, in the home security industry, we already see various cases where mechanisms to pre-process raw video data out of video content are directly applied on the edge before anything gets uploaded to the cloud. And this is just one example, though, since there will be many other areas where privacy will strongly advocate for on-edge processing. Two examples can be devices that collect fitness or heart monitoring data, as you may not want anybody else to know what is your health condition. Or another example could be devices that monitor electricity or water consumption. Exposing this data could help a hacker, to know if you're at home or not. So these are just two examples of, where you, as the customer, might prefer your data to be processed on the edge.
Yeah. And one other thing I would say in there too, Andreas, that you probably see too, is just with all the different regulations of every country is actually storing it at the edge. It just helps us be more in compliance with local laws, because then if you just store it in the home country, then we don't have to worry about, like, is it being exported out of the EU? Is it being exported out of the UK? So having a smart edge device that can store all the data is just very helpful for everyone.
Agree. Yeah, just a reminder to the audience, feel free to drop questions, anything you're curious about in the Q&A section. So Nigel, back to you. I wanted to ask you about on the industrial side of things. So industrial businesses have been talking about IoT adoption for the past decade. It feels like longer to most of us, but where are they on that journey? And is there meaningful tech change now or on the horizon that's enabling this accelerated adoption?
That's an interesting question, Joe. I mean, we've seen, we have customers and interactions where, you know, when we talk to them about what we provide in terms of edge computing, their first response back to us is kind of chuckling and saying, you know, we've been doing this for decades. It's just that the tech industry is now calling it edge computing, right? Whereas for us, we've always been doing this. So I think there are some companies, some applications where this need was ever present and you had to do it at the edge, right? And in particular, you know, things where you don't have connectivity. So you're in a remote oil and gas field, for example, or you just have so many sensors that you don't want to deal with all of those sensors coming to one central location, for example, on a manufacturing line. And that's combined with, I need low latency, right? I need to be able to do some of the response very quickly to manufacturing processes. And so I think that some of these industries are farther along than we think. They're just not calling it edge computing. That being said, the volume of data that we're producing today is growing exponentially. I think, you know, potentially that same Gartner report, Joe, that you referenced at the outset, I think mentioned that within the next 5 years, we're going to see about 175 zettabytes. I think that's 10 to the 21st, if I'm not mistaken, of data being produced at the edge, right? And there's just no way you can actually process that or move it, ship it around. And so I think that's really what's driving this, and the ability to use more complicated algorithms, right? So being able to do more complex things, to aggregate more data and to make a smarter decision is really what's going to drive a lot of these industrial players to doing even more than they might already be doing. I think that's where we generally see things going, and where our customer interactions have been so far.
Yeah, and I would just jump in and echo what Nigel was saying. From what we see from industrial customers, like they've been doing this forever. They've had tons of devices, and what's really changed is those edge devices are getting smarter. They're getting connected so that you can run algorithms and analysis on all that data. I think one great example of this is a company called Samsara. They've connected all these IoT devices at the industrial layer, put a cloud layer on top to essentially aggregate this data, analyze it. So what we see a lot from the industrial side is just the ability to get smarter devices in there and cloud connect it, analyze the data, and actually make better business decisions based on all this data that you now have. So yeah.
There is one thing I forgot to add or mention here, was that one area we're seeing a lot of interest in industrial controls, even on engines, is the ability to have digital twins. And what that means is to be able to model the process, right? The engine process or the manufacturing process simultaneously or ahead of when you may make some configuration change to that process. And what that allows these customers to do is essentially say, yes, I've validated this configuration prior to sending it out to a physical control, so that you don't end up in, say, a Stuxnet situation, right? Where someone's essentially sabotaging your industrial process. And so, you know, that feeds into the complexity of algorithms that people are seeking to run today. And I think that we'll see that becoming more and more prevalent in deployment, and will drive more of edge compute as well.
Excellent. Going back to Garrett, so Garrett, it's well known that one of your competitors had a devastating and quite public data breach. So could you help the audience understand how we should think about security at the edge? What makes it different than security in the cloud?
Yeah, so security is something that we live and breathe over here all the time. I mean, we're securing large enterprise organizations, people that have a lot of compliance restrictions, as we're kind of talking about some of these privacy regulations. So it's something that we think about. We come from a cybersecurity background. And the other thing is, and I'm sure everyone here can talk to it, is edge devices, and particularly like cameras are one of the most hacked devices on the internet, just given poor security hygiene from other vendors in the past. So I think in general, when people look at these types of devices, they need to make sure that they're looking at companies that have a security first mindset, have a privacy first mindset, that they're taking good hygiene. They're looking to outside parties to test and validate what they're doing. And I mean, edge devices do present a bit of an issue, because now you have all these devices that are internet connected. They have points of connection to the internet. And so there's always hackers out there looking to do malicious things to those devices. You mentioned one of our competitors. I think one of the things that us as vendors have to be really careful about is what types of internal access do we have. Them and some other large public tech companies in the past have gotten hit because they have enabled what's called a God mode. Those are usually just things that you don't want to do as best practices in hygiene. You just don't want to have where you have internal access to all your accounts. And something that we've never done, just from a privacy standpoint, is that we've always taken a permission first based approach, where we want to make sure that our customers are granting us permission before we can actually look at anything. So lots of considerations in this area, but it's really incumbent upon all of us as edge players and cloud connected IoT devices that we're always thinking security first.
Andreas, what do you think how is it different on the consumer side?
Yeah, I mean, first of all, it's a very important topic, and I'm glad that you brought it up, Joe. I think that, data breaches often happen when old IT and new IT are evolving together. And there is a whole debate about standardization, or better said, a lack of standardization in many areas of IT. And this is relevant when talking about security at the edge and in the cloud, especially when you have an emerging new industry. Every company tends to do their own thing, which can cause security concerns. And therefore, this increases the chances of architectural breaks and risks within the security system, thus putting a huge burden on the end customer and the system integrators. And our advantage is that we have an end-to-end controlled value chain, and the platform when it comes to both our software and hardware. And this allows us to process data securely on the devices, but also at the same time to transmit it in a secure way into the cloud. To give you an example, Canary smart security devices are amongst the most secure connected devices on the market today. We are, in addition to employing best-in-class encryption practices, as Garrett was saying, Canary also takes several measures to ensure the privacy and security of all our users, to mitigate and prevent unauthorized access of their accounts and the devices attached to their accounts. So this means we need to ensure security at the edge, in the cloud, and also when transmitting the information from one to the other.
Excellent. So just as a follow-up to that, we've got an audience question from Jason Seidel. Thank you, Jason. It's just security and actually a previous topic on privacy. So do customer-owned encryption keys provide enough protection on these privacy and regulation issues with cloud storage?
Yeah, I can take that. So there's definitely—
Anybody have an opinion on that?
Yeah. So there definitely could be customer-owned privacy encryption keys, and that is a way to really ensure that only the customer has access. The only issue sometimes with customer owned, or I'm sure, I mean, there's essentially pluses and minuses. One of the minuses of it is that the vendor can't provide any business logic on top. So the example I like to give here is, let's say box.com, they allow you to have customer encryption keys, which they might even allow you to do that. Well, none of the search features will work within box.com because they can't see any of the data. So it's sort of a plus and minus of both. It's great because it really ensures the security. The minus is you don't get any of the benefit of like search or algorithms or anything that can help analyze that data.
Maybe I have a question for Garrett along those lines. Do you see this being potentially a problem in customer being responsible for it? I like in a past life, I was in the crypto space, and managing keys is not the easiest task, right? In a secure way. What's your viewpoint on that?
Yeah, I would totally agree. So same thing in a past life, in my past company, this was a hot topic, was giving customer encryption keys. And what's funny is it seemed like all the rage to me like 5 or 7 years ago. I haven't heard it as much just because it is technically complex to deploy. It puts a lot of onus on the customer. And what we find a lot is part of moving to the cloud and to the edge is that customers want to have a little bit more simplicity so they can focus on their core business and not worry about this. So they're really just looking for vendors that, like, as Andreas was saying too, is really go above and beyond in protecting their security so that they don't have to worry about it. There are obviously some industries where they want the benefits of the cloud, but they need to ensure a very high level of security, maybe like federal agencies. But we don't hear about it too much in our industry anymore, just because there is a lot of technical challenges in actually implementing it. That's a good question.
Excellent. So let's go back to Nigel. Curious as to your thoughts. What are the challenges faced by edge computing providers that are different from hyperscalers like AWS, GCP, and others?
Well, I'd say, anytime you're talking about something that's non-centralized, you have a completely different set of challenges, right? Just think about the simple task of debugging something that you're not in close proximity to, or you have different kinds of failures or different kinds of algorithmic challenges based on different data sets that you don't have access to, right? So I think that's where a lot of the challenge comes in with edge computing in terms of how it differs from computing in the cloud. Specifically for hyperscalers, I think the management of those devices becomes a lot easier. That being said, I mean, I would defer to Andreas and Garrett in terms of pure management of devices. So I think there are companies solving that problem on the edge. But I think the nature of the compute itself is changing in terms of what's being processed in the cloud or on a hyperscaler versus what's being processed on the edge. And so, there's always going to be room for those people, for the hyperscalers, AWS, et cetera. But what they end up processing is going to be different going forward. I think it'll be processing more of training, especially as we go into, deeper into the world of neural networks and advanced machine learning, where you have these huge data sets that you're just not capable of processing at the edge, right? So I think the nature of the compute is what's changing. The management of the devices themselves will probably solve themselves. I think we have smart people and smart companies out there working on that. So I think it's really about the compute itself.
Yes, I agree with Nigel. There are definitely many challenges and unknowns that still need to be resolved. One of the primary ones will be finding the appropriate way to distribute infrastructure resources and to manage virtual machines and containers under an edge type model. So to do so successfully, it will be required that the industry develops standards, coming back to the question about standards again, that specify how various computing components should collaborate and allocate resources, even when different infrastructure suppliers are involved. And that may take some time. Especially since there is still much research to be done on the best way to delegate tasks to other network nodes, either because more resources are needed or there are location requirements involved. So that will likely require a full understanding of the limitations of the other nodes and consideration of various delegation strategies before a final decision is made. So I think there's a lot of homework that needs to be done in that space.
And I would say on the day-to-day pain of running edge devices is it's amazing how hard it is just to get these things connected to the internet sometimes in an environment nothing about. customer will call in and say, I can't get something online. And it's like, there's a firewall rule blocking it. There's DHCP servers no longer handing out addresses. It is just in the weeds of it all. Just getting devices online sometimes can be one of the biggest issues versus a homogeneous server environment that some cloud player has.
Excellent. I want to mix in another live question from the audience. This one comes from William Paul. Thank you, William. Curious about when we talk about capacity and bandwidth, whether you think the bigger leaps for the edge, maybe specifically node storage and processing, will come from advancements in quantum computing. Curious to what you guys think.
I might take that one since we're probably closest to the actual computing part of it. So I would say, look, quantum computing, I know there's been a lot of media coverage over it and the possibilities there, but, take a look at the pictures in some of those media articles of what those devices look like too. They're gigantic, right? They're not what you can't fit 1 billion transistors on a square millimeter. When we're talking about quantum computing, you can't do that. So are the potential capabilities vast? Yes, but a lot of it is just now coming into some infancy in terms of realization of those possibilities. I think it's going to take, a long time, many, many years before we see a quantum computing really hitting the edge. So I think there will still be, unless there's some notion of, quantum bandwidth that you're able to exploit, I think we're still going to see a huge shift from or to edge computing because of all the things that we've talked about. I don't see quantum really being a player in this space anytime soon.
I think Nigel summed it up well. I don't even think that.
Okay, fair enough. Fair enough. So quantum will be centralized for some time. Here's another question that was submitted from the audience ahead of time. How do you split the application between the cloud and the edge? And how do you overcome the technical barriers for doing that? Andreas, would you mind taking this one?
Yeah, sure. So it's a very good question, and we are thinking about this topic a lot. So, with intelligent video processing, we are generally in a data-intensive category. However, the interesting thing about IoT in general is that only a little bit of the data generated is actually valuable immediately, and with the remaining data set aside for future processing and improvements. So this means in most cases, we do raw calculations on the device, and only the result is being pushed to the cloud for further refined analytics and processing. For example, let's say our camera does detect a movement. Then the first step is for us to define if the movement was generated by a human or something else, for example, a pet. So unless our customers choose different settings, we would consider only movements generated by humans as relevant incidents. Therefore, only these type of movements are being pushed to the cloud. And in the cloud, we are running them through a refined proprietary analytics, such as the Canary Vision framework, to determine if the movement detected is a potential threat and the event needs to be escalated or not. And so with regards to technical barriers, we've developed our own proprietary edge to cloud based architecture.
Yeah, I don't know, Joe, if you were looking me to add anything else. I think Andreas summed it up well. I mean, we're always looking at how can we push more to the edge, just for, as we've discussed this whole time, how to get faster analysis. And I think also selfishly as cloud vendors, or selfishly as vendors in this space, like the more compute you can push to the edge, it saves costs on the cloud compute side as well. So there's also a financial incentive to push to the edge as well. That's pretty much all I'd add.
So quick question to both of you on that particular point when it comes to cost. I mean, we've seen cost go down even in the data center, right? Just like, if you define your metric, right? Gigahertz per dollar or dollar per gigahertz or whatever it is, right? So how do you see that, right? Because at the end of the day, to do edge computing, you have to put some hardware on the device, right? Some compute hardware on the device. Now, obviously in our minds, we're trying to make it cheaper for people to do that compute on the edge, right? But how do you guys see that?
In terms of like, is there?
Well, right. You're seeing cost savings or cost per performance go down even on the data center side, right?
Yeah, it's still, I mean, AWS and Google Cloud, they're still good at charging you. They find ways to charge you every which way around, at least in my experience. Maybe Andreas is much better at it, but we find that the more we can push the edge, it ends up saving us. A good, easy example of that is storage. Like, no matter how you slice and dice it, and even though it's getting cheaper in the cloud, like storage is still expensive, especially the type of data that Andreas and I are generating. There's a lot of video data, and you can fill up a lot of S3 buckets really quickly. So the more we can push to the edge, at least in our business model, it helps a lot.
Yeah, I agree with Garrett. Same here for us in the B2C model. The more we can process on the edge, the better for us. At the end, it's all about unit economics and to make sure you have a viable business model. So in our case, it means that, we will need both in the future, increased processing power at the edge, and then also hyperscalers as partners for refined and complex calculations and data storage.
Very good. And Nigel, I appreciate you asking questions of the other panelists. That keeps things fun and dynamic. So we're getting towards the end here. I'd love to ask you each one kind of final closing question, which is, we'd love to get a picture from each of you of the future. So this is your chance to put out a bold, contrarian prediction on where this space is heading. So Andreas, let's start with you.
So how bold can we be here, Joe?
Sky's the limit. Sky's the limit.
I think, following the augmented reality and metaverse discussion, IoT edge devices are providing the role of input from the sphere that would actually interact with the human sphere in virtual reality. So this means in the future, there would be a massive amount of sensors in order to create these hybrid metaverses. And, every element in the future will need to contribute in giving its identity to the metaverse, whether it's a haptic glove, a smart lamp, a camera, or a pro game audio headset. So the implications for home and shopping are massive, and all industries will change. So we are essentially creating the things metaverse at home. And then if you take it from the home to the city level, then we would be providing the things metaverse for a smart city. So this is not just about a virtual world, it's about interacting with all the complexities around you and making them safer. And that's a little bit of how we see the future in terms of IoT and metaverse.
I can go next, although I'm hesitant to go after that. I mean, that sounds way more interesting than anything I was going to say. I was going to talk about the, for what I see in kind of our limited scope of the world, I see an explosion of use cases for cameras. So I think you said a stat, maybe it was you, Joe, or Andreas at the beginning, that we're going to go from 8.7 billion IoT devices in 2020 to 25 billion. I'd argue it's going to be much more. And the reason I'd argue that is I think the computer vision use cases are going to explode in all different types of ways that we didn't see coming, especially like we talked about industrial, we talked about like manufacturing, you can think about retail, and this can go for things as the processing power becomes much better on the cameras and the modeling becomes much better. You can do things like in the construction industry, like, hey, are people wearing hard hats? Are they wearing vests? In retail, you can do all types of interesting retail analytics. In manufacturing, you can do all types of QA, like are things getting manufactured correctly? Places where there was using human eyes or no eyes before, I think there's going to be all types of eyes to help efficiency in all types of processes. So that is my bold yet not as interesting as metaverse vision.
No, I absolutely agree with you, Garrett. That's and also it's probably much closer to what's going to happen tomorrow.
But the metaverse stuff is so much more interesting.
Yeah, I'm hesitant to go after the metaverse as well. I think my take on this is that some of this tends to be cyclical in the sense of, we started off with mainframes and we all did, well, not all, but people did work on mainframes because we just didn't have the compute power at the edge, being your desktop at that point. And we were relying on the connection, right, at that point. Then our compute power got better at our desktop, and then we had the explosion of the World Wide Web and all of that, and so we saw this migration back to cloud, especially with the explosion of mobile devices. But now we're starting to see again this, compute power, as we've all mentioned, is going up relative to the bandwidth. So, and we're just producing more data at the edge. So I think we're going to stay in this regime for quite some time, where more and more of the compute is going to be shifted from the cloud to the edge. I don't see that shifting back anytime soon, or the pendulum going back anytime soon. And we all want faster answers and secure answers, right? That's, I think, a high level point we can all pretty much agree on. And what that means is that we want the compute as close to the data generation as possible.
Well said, all three of you. Thank you for that. And Nigel, you also may have inadvertently answered another audience question. So appreciate you doing that. Or maybe it was purposeful. So, okay, well, that's about it here for Cota Access. I want to thank our three amazing panelists. We really couldn't ask for three more educated experts to have on this panel. So we appreciate you. And for all the attendees here, thanks for joining Cota Access. And I have one last thing to share with you, our legal disclaimer. So please take a moment, review the disclosures on this slide. And thank you once again for joining Cota Access. I'll leave this up to allow you to finish reading if you so choose. But thanks again to our panelists, and thanks everybody for joining.